All right. We're going to talk about Python and interface programming and such, and we're going to see if we managed to utilize some of the functions that Neil puts into the Sub Academy. So, in the input device week, there's a bunch of files, example files that can be used, most of them being either a C file, raw C files, or Python files. So let's see if we can kind of backtrack and see if I can explain a little bit to you how that exactly works and how you can use this to your advantage um, when when working with some of these examples. So. So for example, over here we have the motion detector. So that's basically the motion detector that I showed you the first time around, and it either detects someone moving or it doesn't detect someone moving. So either it's sending a zero or a one, a on or an off signal. So this is all written in C. So this is the more complex version of Arduino. Arduino is also C, but this is just the very core C that obviously we don't really expect you to work with at the moment. But if you were to take a look at this, you would see some similarities with this as you do with the Arduino IDE. And what this code is doing, mostly over here in the main void, it's doing just a while loop, and it's seeing if it gets an input from the sensor, and if it gets a high input, it sends a one, and if it gets a low, if it doesn't get anything, it sends a zero. So it just sends a one or a zero to the serial line that the computer can work with. And in his video, he basically shows this Python script that either detects motion or not, and it displays a blue color when it doesn't detect any motion, and it displays a red color when it does detect motion. And it does that in the computer, and the computer is actually taking the input. So this is the same input as you would get from the serial monitor. So here's an example Arduino script, and if you were to just go here into the serial monitor, you would get the same code, 0 or 1. And here is a mock code. Here is just a very it just mocks it just mimics what is happening, and here I actually have a 2 instead of a 1, but 0 or a 2, it doesn't matter, because if we then took a look at the code, if we took a look at the Python code over here, this code seems very, very complex, especially if you don't know what is happening over here. But this is just an import library, just very similar to an Arduino library. So if we were to say, you know, include library, and we could include any library you wanted, let's say EEPROM. So this is just an include library. In the Python version, this is including a library called tkinter or tkinter. And then it's also importing the serial library, because we want to be reading the serial line of the computer. So we want to see what is actually happening. Then it goes into it makes the graphical interface. It checks to see if there is something on the communication line, on the USB line. Then it goes, well, this is the setup of the interface, and this is what the interface is actually doing when it's displaying red or blue, off or on, or rather motion or off. And then it just goes back up again, and it goes round and around and around. But the question is like, yes, here's a code. How do I actually use this code? How do I activate this code? And for that, we need to have Python. And Python is a scripting language, and it has a lot of compilers or programs that can actually run the code and do something for us. And if you're running Windows, the Windows environment is, you can use that. If you're running Mac as well, Mac actually has a built-in Python. Mac has a built-in Python, and Ubuntu or Linux does as well. Now, I decided instead of doing this in the Windows environment, which is not very suitable for coding like this, I decided to actually use this on a Raspberry Pi. So here I have a Raspberry Pi, and just to show you quickly, I have my Raspberry Pi here connected to my computer. And the Raspberry Pi is then connected with a serial input to the microcontroller, to my Hello World board, and we're gonna be using this. I choose to do this through the Raspberry Pi mostly because I have a better access to Linux and the peripherals that is the USB ports instead of using the computer, my desktop or rather my laptop. So I'm just here in a virtual environment with a VNC viewer, and my Raspberry Pi is here on the table, and I'm going to use the Pi as a developing environment for us to send the code through the computer and then read it through the Raspberry Pi. Now, the nice thing about the Raspberry Pi is we also have, or the Linux environment, we have access to the terminal window. And a terminal window is also something you can find on a Mac. The command prompt in the Windows environment is a little bit different. So the Debian-based ones that are the same in Linux and Mac is very nice. So what I can just do quite easily is to find the code. Here it is. Copy the address, copy link address, and then I can do wget, and then I can paste the address, and then it will just download the code and save it into my repository. So I already did that, so this is just a copy. To run this code, to run this, I actually want to first upload the Blink that we did. So I'm just going to send a 1 or a 0, a character 1 or 0, to the Raspberry Pi through the serial port, and the Raspberry and my attiny 1614 is just going to send 0 or 1 with half a second interval. So let's just do that. We'll send the code, and then after we've sent the code, I can go into my terminal window and I can write just Python. For Python 2, we're gonna use Python 2 for now because the Niels code is dependent on Python 2. Python 3 needs code adoption. So for Python 2, we're just going to do Python, and then we can write the name of the file, which is hello rcw.py. Now this isn't enough because a line in the code asks for the serial port, and we haven't specified the serial port. So for Linux, we do dev tty USB 0, and 0 is for the USB that is connected. It is the only USB that is connected right now, so this will suffice. And then we get just a graphical interface that then goes, on motion or off in a half a second interval. I could change this in the Raspberry Pi, and I could say, do this with a second interval, 1 second interval, and then after it's loaded, we can go back, open it up again, and this is much slower now. So you can see now how handy it is to be able to take data in from a Pi, or sorry, from the microchips, the microcontroller units, and work with them in the computer display. So with this, we could take the Pi, we could connect it through, well, in this case, the serial port, but the Pi actually has some GPIO pins as well, but that's another story. And we can document the data. We can save the data and we can do something else with it. We could have this display a different type of image, or we could, do something else. I'll just Q to exit, and then, in the terminal window, this is a method for opening up the code. But if we were uncomfortable with using the terminal window, we could also use an environment that is supplied with we can use a compiler. And here is a compiler for Raspberry Pi. There are tons of compilers out there. This works just like the Arduino IDE, but this one is specific for Python programming. So here, this is a compiler for Python 3. So we're not going to be using this for Neil's code, but I have written some sample codes. Now here's a sample code that we can use, and just to show you how Python works with Arduino. Here is a little bit modified code. This one has just double quotation marks, and the code we just uploaded previously has a single quotation mark. Now this is a character. This is this is a different kind of signal. So if we send this, so this is a character interpreted by the ASCII. That is the symbol. That is the bit symbol for how a computer interprets our letters. So this would be a letter on the computer, whereas this would be a number, actually. So if we run this, if we just press run here, we get those, we get the characters, alternatively. So we can actually use the compiler to run our code, and our code will show here in the shell. And now, if we wanted to use the terminal, we could do Python 3, and then we could run this read data example.py. Now in the code I have specified, exactly where it needs to read the serial line, and this is specific for the Debian environment, and I think this would work for the Mac as well. But if you were to use a Windows machine, you would have to write COM 1 or 2 or 3, depending on where your serial line is connected. But and you can see, you also know that from the Arduino. That's the COM 8 here. But since we're using the Linux environment, this is how you specify where to find the serial data line and where to read from it. So we're just going to run, so we can run this code from the terminal as well, and it would just display in the browser or in the shell. So here we also have a shell. So this is how we can take raw data from the Arduino, and we can place it into a different environment than the Arduino, since we're quite used to using the serial monitor in the Arduino IDE. But now we want to use something else. We want to take the data and we want to do something else with it. And Python is actually really popular and really easy to learn. Much easier to learn than C, for example. So Python is a really good place to, or rather, Python is a very good multi-purpose language to learn. So yes. Now we've been reading the data and we can change some of the variables in the Arduino, and we can actually take more raw data and we could display them in a different way. Now, if we wanted to add some features to this, we might want to talk to the Arduino. We might want to tell the Arduino when to send us data, or what type of data, or where the status is. We can actually use something along this line. So this is a code that I borrowed from this YouTube video, and this series is quite good. Now, what this code does is it reads from an analog pin, and in this case, it's pin number 3. And so here's an integer. Integer is a numerical value. Here's another integer. This is a variable, and we just call it data, and then we initially put it to 0, and then we have a character input that we can get from the user. So here it just initializes the serial, and it initializes it with 9600 baud rate, and then it goes into the loop. It checks to see if serial is available before doing anything, and then it looks and sees if there's some input from the serial line, and if the input is G, then it actually sends the data. So let's just upload this into the microcontroller and see what happens. So it gets uploaded, and then we can see the code over here. Now, what the code does, it does something very similar. It just imports the serial library. It puts the serial into this variable ser here, ser, just like we did in the previous example. And then we have two commands, two functions. One is a define function, get values. And it says if it actually does, it sends the letter G as a bit. It sends it as a bit value, and then it reads what the Arduino sends as an ASCII value, so as a numerical value, or as actually a character value, and then it goes back into the Arduino data. So it goes back into reading from this line. So what this does is if we press, so in the user input, we say get data point, so that's over here. And if we press Y on the keyboard, it actually sends us the values. So if we run this example, over here in the shell, we have a prompt. Do you want to get the values? And we can say Y, and then it sends us a value point. So this is the value on the analog pin 2. On the analog pin 3, sorry. There is nothing connected to this analog point, so it just gives us an arbitrary number, something that it might have a static or something, but it does change. So we can say Y again. If we say any other keyboard input, it doesn't give us anything. It has to get the value Y. So we can take a look at the example again. So it sends the letter G over the, it accepts the letter G, so the G is over here. And if it gets the letter G, it sends the data. That's all it does. Now we can manipulate this code and do something else. So I did write a very simple program to do something similar to this. So here is a motor. Let's say we had a motor and we wanted to do something with the motor. Now in the Arduino code, we have a little graphical interface here. So if we run this code, actually let's stop this. And so if we run this code, what this code does is you can click on the button, and then the button either sends a 1 or a 0 to the Arduino in return. So let's take a look at the Arduino code. Now we have two if statements, actually three. So this is just a serial line. Is serial available? And if it is available, see if you can accept a character. Now, if the character is 1, then just turn on the digital port. And if it is a 2, then turn off the digital port. It's a simple turn on, turn off again. Let's send this code over the into the tiny and see what happens. So if we ran this code over here, it happens so that I have the values over here. So over here on the, you can see on my voltmeter. So basically what this program does is if you turn the motor on, the line goes high, and if we turn the motor off, the line goes low. So now we have a graphical interface with connection to the Arduino. So this is in essence very basic, but hopefully you can understand this code much better than Neil's code over here. So let's take a look at Neil's code again for just a moment. The big thing here is the graphical interface. The code, what is running behind the scenes, is very basic. It's just accepting a character input. It's just accepting the data, what is happening. And if the data is in line with what is sought after, then something happens. If not, then nothing happens, or it goes back into square one. Now, hopefully, with this information, you can use some of the example files here and use them to your advantage on what you want to do. So that's it for now. Thank you.